Let's talk about finding the interval and radius of convergence of a power series. Find the interval of convergence of the power series summation n goes from 1 to infinity of 2x plus 1 to the n over n squared. Well, we use a ratio test to find the interval of convergence. Recall how that works. We look at the limit as n approaches infinity of a sub n plus 1 over a sub n, an absolute value. So we know what a sub n looks like. A sub n term, to find the a sub n plus 1 term, you just replace the n's with n plus 1's. Now we combine, we put together like terms. So this is going to be, when you rewrite this fraction, you end up with 2x plus 1 to the n plus 1 over 2x plus 1 to the n times n squared over n plus 1 squared. Lots of cancellation going on here. This just simplifies to 2x plus 1, and this is going to stay n squared over n plus 1 squared. So we can pull the 2x plus 1 out front because it doesn't even have an n in it. So we just have the absolute value of 2x plus 1 times the limit as n approaches infinity of n squared times n plus 1 squared. You can use L'Hopital's rule or some other principle to find that that limit's 1, and so we just end up with the absolute value of 2x plus 1. Now recall how the ratio test works. The series diverges if 2x plus 1 is greater than 1, and the series converges if 2x plus 1 is less than 1. So let's rewrite that. Absolute value of 2x plus 1 is less than 1. That means 2x plus 1 is between negative 1 and 1. Subtract 1 from all sides, we end up with negative 2 is less than 2x is less than 0. Or if we divide all sides by 2, we end up with negative 1 is less than x is less than 0. So we're almost there. We just need to test the endpoints, negative 1 and 0. So let's test x equals negative 1. When you take this series and plug in x equals negative 1, you end up with the summation of 2 times negative 1 plus 1 to the n over n squared. Well, 2 times negative 1 is negative 2, so what's in parentheses here is simply negative 1. So we have the sum as n goes from 1 to infinity of negative 1 to the n over n squared. So we have negative 1 plus a fourth minus a ninth plus a 16th. This converges by the alternating series test. So the series converges for x equals negative 1. Good to know. Now let's try x equals 0. When you plug in x equals 0, all of this that's in parentheses just simplifies to, well, that's just all going to simplify to 1. So we have summation as n goes from 1 to infinity of 1 over n squared. That's 1 plus a fourth plus a ninth plus 16th, blah, 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 blah. And that converges by the p-series test. Here we have p equals 2. So the series converges for x equals 0 as well. So really our answer is going to be, I haven't stated what our answer is going to be, but our answer is basically going to be negative 1 to 0. Okay, that's our interval of convergence. Find the radius of convergence of the series. Well, the radius of convergence is half the width of the interval. The interval from negative 1 to 0 has width 1, so the radius of convergence is simply a half the width of the interval of convergence.